For the final step in this example, let's go ahead and compute some box heights based on the distance from the attractor point, very much like we did in the prior example where we're computing some circle radiuses. We're going to use the geometry distance to function and just really look at the placement points for all the boxes versus the attractor point. And then once we have that distance, just scale it up a little bit. We'll use a scaling factor, divide it by the distance to the attractor, add a little bit to it because I want to make sure that, again, the height isn't 0. So we have to always go through, especially when we're creating Revit elements, make sure we don't end up with zeros floating around in there or infinite. And once we've gone through and computed that height, we're going to just use those values to element set parameter by name. We'll take that list of the box elements and just set the height parameters to that list of values that we've computed. Okay, so very similar to what we did in the Dynamo geometry. Let's just see how it's implemented here. So here I've downloaded step 3 from Canvas, and you can see I have my attractor points set up. I have my geometry distance to function over here. So what I'm going to do is just connect those two things together. We're going to take that list of points, the flattened list of points. We're going to take this attractor point. So we have a bunch of different things, and we're going to compute those distances. And once we have those distances, we're going to just basically scale them. So we're going to choose the distance. We're going to have this scaling factor. Okay, and let's just go ahead and run that so far. Okay, that wasn't too awfully bad because, again, we were mostly just working with some Dynamo mathematics. If I come back and want to take a look at those different values, let's see if I can do that. So these are the different height values that I have. Now the important thing on the height values, I just want to make sure that they're all greater than or equal to, or actually greater than 0. They can't be equal to 0. So I have to make sure that we have some positive heights because I can't create a Revit element that has a negative or a 0 height. So what are we going to do? We're going to set the parameter by name. And what we'll take is those same family instances, all those different elements. We're going to set the height parameter to be those computed values. And when we do that, it'll again take a little bit longer because this is going to go through and for all those 100 boxes, adjust the heights. See what it looks like here. That's not looking right now. Oh, I'll tell you what's going on here. I have several different instances on top of each other. This is always a problem I have when I'm kind of sort of jumping between these different scripts. Let me go through and select all the instances. Okay, and I'm going to rerun it. Again, when I change between my different example scripts, because I'm opening new scripts, it's losing track of the elements that were created by the prior scripts. So we just have to run that again. Okay, and this is more about what we have in mind. So based on this, I'm seeing the attractor point over here in the corner, and you see the heights kind of dipping down. So you might actually see this is more like a depressor as opposed to an attractor. Let's go over and take a look at those sliders and see if we can adjust that. Yep, so we're sort of up in that upper right-hand corner. So if I want to just pull more back towards the center of the grid, I can do that. Let's run that. Okay, this will just go through and recompute all those heights. So now we have the depression in the middle. Okay. We could also go through and adjust it the other way. We could go through and, as opposed to kind of dividing through, taking the distance and dividing by the scaling factor, we could divide by the distance. If you divide by the distance, that has the effect of accentuating. So let's just try that so you sort of see what that effect looks like. If this, and I divide through by the distance, now in this case, since I have the distance in the denominator, I have to add the 0.01 there, because again, I can't be dividing through by 0. Doesn't like that. Let's go adjust my code block a little bit. Let's see what this looks like. So in this case, the height's going to get quite a bit bigger when the distance is close to 0. That's a little non-dramatic there. It's actually just sort of very localized. So what can I think about? Oh, let's say this. It's that divided by that. Let's try putting in a smaller value here. I'm very experimental about this in terms of trying to create the effect I like. No, that didn't have very much of an effect at all. So what do I want to do? How about, well, we can kind of keep on playing around with this effect. And what's going to happen is we'll just kind of change the effect of how broad or how tall, just kind of play around with that to kind of create the desired effect. But I'll let you guys go ahead and do that on your own. So here is the end of this example. So again, this example just shows how you can implement the attractor logic using Revit elements. The big important thing that's different is that you're going to be placing some family instances by point, as opposed to just kind of creating geometry by those points. And then you're going to set parameters of the elements, okay? Making sure that the parameters that you're setting are always valid ones.